So whatever that you have done in O levels, in AS level, with Visual Basic, with C++, with Python, whatever, that comes under the umbrella of imperative languages. And imperative languages are also called what? Imperative languages are also called procedural languages, but we do not use that word because that contradicts with your understanding of procedures and functions, and also we will still be calling it imperative languages. Alright, so other one is declarative languages. Now you might ask, sir, why there is low-level programming language and object-oriented programming language is different than imperative languages. These are different ways of programming, but they still come, low-level language and object-oriented language, under the umbrella of imperative languages. We will discuss about it. So today's topic is declarative. This is another paradigm. So what I was trying to tell, that there are two types of programming languages. There are two types of programming languages. One is imperative. The other one is declarative. Get the idea? So imperative and declarative. So our topic today is just the declarative ones. So declarative programming, this is the topic. Okay, now what is declarative programming? You might have heard of expert systems and artificial intelligence, that sort of languages. They do not use if, then, else and loops like for loop and while loop and repeat loop. There is some sort of decision, but not the way we know of. This is a different scheme of work, declarative programming. Here, what they use rules, they use facts. This is a complete different system. So basically, declarative programming uses statements of facts and rules together with a mechanism of setting goals in the form of query. So whenever we set rules and facts, we will discuss about it shortly. That what are rules and what are facts and how they actually work. When we write rules and facts, then we query the system, and system answers us. And the query is called goal. A fact is a thing that is known. Get the idea? A thing that is known. Alright, so my name is Zafar, that's a fact. And rules are the relationship between the facts. We will discuss about it. Let's say there is a person called Saf. I'm also a person called Zafar. So Saf and Zafar are rules. And we both are brothers, Saf and Zafar are facts, and we both are brothers is a rule. The relationship between the facts is defined as rules. So we will discuss about it shortly. Writing a declarative program is very different to writing imperative program, as we have just discussed. In imperative programming, the programmer writes a list of statements in order that they will be performed. We know that a computer program in imperative languages is a collection of number of statements, and computer executes those statements one by one. That is why we call our computer a sequential machine. But in declarative programming, a programmer can state the facts and rules in any order before writing the query. Alright, so facts and rules do not have any order, so system actually does it itself. Okay. First of all, every programming paradigm is achieved through a software, which itself is called a language. So we are going to use a language which we call Prolog, programming logic. Prolog. Let me actually pull that up for you so that you could download and practice it yourself as well. SWI Prolog. SWI Prolog. देखें, ये है language SWI Prolog. So SWI Prolog is a free implementation of programming language Prolog, commonly used for teaching and semantic web applications. So this is free. This is from Borland. Alright, so you would have to actually download it. Okay, so go for the stable release and then download for Windows 64-bit, or if you have got 32-bit machine, download it for 32-bit machine. Okay. Alright, so there is Prolog for every sort of operating system, but I'm only concerned with this Windows 64-bit. Okay, so we have got other versions for Linux and others. So just this. So you need to download this, okay, so that we could practice. Now, so which language we are going to use? Prolog. The syntax in our syllabus is as per Prolog as well. Okay, so we will be actually studying it. So let's start. Declarative languages, they use facts and rules. So let's write few facts. Okay, this way we can put comments. So what we are going to write? Facts. So this is basically a comment. Okay, static slash static, and then whatever the comment, and then comment ends at static slash. So you may go on with comments over the lines. So whenever the comment ends, you would have to put a static slash. All right. Then let's take an example of children and their liking for the fruits. So the fact is, let's say fruit, and it's orange, and a dot. Now this is a syntax. Basically, as you know of Boolean algebra and Boolean logic gates, or logic gates only, or their circuits, you know that whatever that is being used is true and false, but whatever that is being produced at the end as a result is basically true and false. So there is another form of algebra which is again producing same true and false results. It is different from Boolean algebra. It is called predicate algebra. Predicate. Predicate algebra. So basically this Prolog is built on that predicate algebra, and that predicate algebra again produces same results as your logic gates or logic circuits or Boolean algebra, that is true and false. All right, so that is basically a kind of language which is basically based on true and false. So look at this syntax. This word fruit is basically called predicate. This could be any word. And this orange is basically called an atom. What do we call it? Atom. Sometimes you may see that it is called constant, or maybe sometimes argument. All right, constant or argument. So basically, first of all that you have to keep in mind is everything that is written is in lowercase. Mind it, even in exam, if you put anything in uppercase or mixed case, or camel case, or initial capital case, whatever you call it, that will go as wrong and you will lose marks. All right, and then this dot. This is necessary to end ends a fact or rule. Okay, so this is the syntax of one declarative language statement. All right, so this is a fact. And what is the fact? That orange is a fruit. That is how we actually pronounce it. Orange is a fruit. And these two words, that is up to you. That is as per the reference to the context for which the program is being developed over here. We are just trying to establish few of the facts. We will look into these facts further with respect to past paper questions, actual scenarios and all. For now, you have to understand that this is one of the facts in which nothing can be changed. Facts are what? As I said, that these are things. All right, fact is a thing that is known. So everyone knows that orange is a fruit now. Not known in terms of that we know of it. It is known in terms of that we dictated it to the computer. So orange is a fruit, dot. So this is one of the fact. And fruit, the word fruit is called predicate. Orange would be called atom. And this dot will be used to end the fact. All right, so now let's say another fruit. Banana is a fruit. This is another fact. Apple is a fruit. Mind it, no space. Even if you see space when I am writing it, please ignore it. No space at all, because afterwards we will be writing actual programs. So for that, even you would have to actually consider this, that we don't write anything with spaces in between. All right. Now let's write another class of facts, and that is for humans. Okay. Let's say child. Let's say there's a name Sabavan. Sabavan is a child. That is how we pronounce it. Sabavan is a child. It's a fact. Then let's say Wali is a child. Another fact. Rizwan is a child. Another fact. So how many facts are now these? These are actually 6 facts. How do we pronounce it? We pronounce it as Sabavan is a child, Wali is a child, Rizwan is a child. Okay, let's write another group of facts, that is likes, Rizwan likes apple. See, now there are 2 arguments. We might have more atoms or arguments. So there might be 2, there might be 3, as many as required. So this is actually an extension in terms of more atoms, but now the pronunciation would be Rizwan likes apple. And then another Sabavan likes orange. And then another Wali likes apple. So what do you see over here? There are 3 more facts added, and now this group of facts, I'm calling it a group because they look, their predicate looks alike. That is why I call it a group. This would have a deeper implication later, but now for now it is. Let's consider it as a group. So there are 3 groups of facts: fruit, child, and likes. Now let's write a rule so that you could understand the relationship between the facts. So we understand relationship between the facts using the rules. So let's write rules. You should ask me, sir, when you say that we don't write anything in uppercase, why do you write this word rules with capital R? So my answer would be, this is a comment. So you may write the comment the way you like it. All caps, camel case, small case, whatever. Okay. So let's define a funny rule. The rule says that, let's say, first of all, the predicate. And in the rule, the predicate is brother. Secondly, rules are applied to any of the facts. They are not specific. Like I said that orange is a fruit, banana is a fruit, apple is a fruit. So these are 3 different facts. And Rizwan likes apple, and Saban likes orange, and Wali likes apple. So let's define a rule. And the rule is the brother rule. So let's say if 2 children like the same fruit, they are the brothers. Like we say that brothers in arms, so that these are the brothers in fruit. So what do we say? We will write it this way: X is brother of Y. So mind it, there is this big difference between the fact and the rule, that in the fact we write atoms in terms of constants. They do not change. So that is why I said that facts are things which are known. Facts are things which are known. Rules define the relationship between the facts. So the first thing that you should notice, that there is no constant. Now X and Y are in capital and they are treated as the variable. So you can put anything in it. So X is brother of Y, and then a colon and a hyphen. So this colon and hyphen is treated like if. So X is brother of Y if X likes Z and Y likes Z as well. Full stop. So commands ended. So you need to pay attention to this rule now. So this rule means X is brother, X is brother of y if x likes z fruit and y x is brother of y if x likes z and y likes z. Okay, so how do we pronounce it? X is brother of y if x likes z and this comma is actually and y likes z as well. So this pronunciation, this wording is actually called atomic sentence. Like, what is atomic sentence over here? Apple is a fruit. Okay, or over here, Rizwan likes apple. So what do we call them? Atomic sentence. So this is an atomic sentence. This is an atomic sentence. And this is an atomic sentence. You might find these things funny, but the thing is, these are the actual wordings. Okay, so atomic sentence. What do we call it? Atomic sentence. So this was one of the introduction. Now, let's say someone wants to find if it is a fruit or not. So we will make another rule. If somebody asks, is it, this is underscore, a fruit? Is it a fruit? What? X. And then we write, yes, it is a fruit if it is found in the list of fruits above. So how do we write it? Fruit X, full stop. What does it mean? If somebody writes, is it a fruit? Orange. The system will see that if that orange X is found in the list of fruit. If it is, the system would say true. Yes, it is a fruit. And if it is not found, let's say if I like, is it a fruit? Inside I write peach. In that case, system will look into fruit, orange, banana, apple. Peach isn't there. The system would say false. Peach is not a fruit. So only things which are known to computers in the form of facts will actually make computer output true. Otherwise, it would be false. Secondly, a last word about these variables. So facts have constants which are not changed. Facts are never changed. All right, facts are never changed. Whereas rules has got variables, and variables may be applied to any of the facts. All you have to do is to change the value of the variable and rules will answer accordingly. So rules are generalized. Rules may refer to facts, rules may refer to other rules, but facts are discrete, they are final, they are undeniable, they are not changeable. Okay, so facts are constants and rules are basically applied to, they are generalized, they are applied to other facts and other rules. Okay, so how does the whole thing actually go further? Before we go any further, let's talk about variables. This y, this x, and this z. What are these? They are variables. Okay, so they are variable. Now, how do we write variable? Obviously, we may write variable as in camel case, means let's say if we are writing name, then N should be capital and AME might be small, or a single letter that is in caps. Okay, a capital letter or a word with all capital letters, or at least the first letter should be capital. Okay, so that is how we actually write these. So let me pull up a few of the programs so that I could discuss those with you. Hold on. Meanwhile, pay attention to what we have done until now. Now check this program. How do we actually write program? We write declarative languages programs simply in Notepad or anything. All right, so whatever the word processor that could produce text. All right, so this should be essentially a text file. Okay, so what are facts? This is with respect to English monarchy, their kings and their forefathers. All right, so actually how it is working, let's see. Hold on. Now see, James 1 is male, that is a fact. Charles 1 is male, that is another fact. Charles 2 is male, James 2 is male, George 1 is male. Catherine is female. Elizabeth, female. Sophia, female. James 1 is parent of Charles 1. So, James 1 is parent of Charles 1. This is a fact. Elizabeth is parent of James 1. Elizabeth is parent of James 1. Charles 1 is parent of Charles 2. Charles 1 is parent of Charles 2. Charles 1 is also parent of Catherine. And Charles 1 is also parent of James 2. And then it says that Sophia is parent of Elizabeth. Sophia is parent of Elizabeth. And George 1 is parent of Sophia. Alright, so this is English monarchy. George 1 is parent of Sophia. Sophia is parent of Elizabeth. Elizabeth is parent of James 1. James 1 is parent of Charles 1, and Charles 1 is parent of Catherine, Charles 2, and James 2. You might be asked by a given scenario to come up with the facts, or from the facts you will be asked questions. So you would have to interpret it yourself. Now there are rules. X is father of Y if X is parent of Y and X is male. You see, being father, being mother, being brother, being sister, is actually rules. Let's say Ali is father of Ahmad. If I ask Ahmad, what is your father's name? Ahmad would say Ali. So if I ask him, is it a fact or rule? So Ali will think from heart. And Ali would say, sir, it's fact. Ahmad would say, Ali is my father and it's a fact. So basically, being father or being mother is not a fact, that's a rule. What is the fact? Being parent. And the rule says that if the parent is male, being male is another fact. So you make a relationship between being a parent and being male. That relationship tells that if they both come together, it makes father, which is a relationship. So relationships are always what? Rules. Being sibling is a fact. And if sibling is a male, brother. If sibling is female, sister. That is very simple. Alright, so facts are undeniable, I understand. But relationships are rules. So it says that X is father of Y if X is parent of Y and X is male. Same goes with mother. X is mother of Y if X is parent of Y and X is female. And then grandparent. Remember, grandparent, not grandmother or grandfather. Grandparent. Now, let's say X is grandparent of Y. X is grandparent of Y if X is parent of Z and Z is parent of Y. Get the idea? X is grandparent of Y if X is the parent of Z and Z is parent of Y. That is the relationship defined. So Elizabeth is grandparent of Charles I. So X and Y. If Elizabeth is parent of James, Z, and James is parent of Charles I, computer will find it out. And computer would say, yes, that's true. And then grandfather. Now, if you pay attention, you may see that the rule of grandfather here is actually not just referring to a fact, but also to another rule. Over here, this particular rule is only referring to facts, parent and male. This rule is also referring to facts, parent and male. But this particular rule is referring to a fact and another rule. So, X is grandfather of Y if X is grandparent of Y and X is male. Alright? And then the last one, X is grandchild of Y. X is grandchild of Y if Y is grandparent of X. X is grandchild of Y if Y is grandparent of X. That is very simple. So let's put it all together and let's ask computer if computer could understand all of this. Okay, hold on. Now see, I have this prologue installed. So as soon as I make a program, let's say I'm going to make a new program in Notepad. I want to write facts. And few rules. And rules are like D, X, comma, Y, colon dash, A to X and B to Y. Alright, so this is just one example program so that you can understand that how we will actually write the program. So when you write what declarative language program, you would have to actually not just save it, you would have to actually make it save as. Alright, and then you will name it abc.pl. And over here, save as type, you will write all files. abc.pl, all files. Okay, now you can see the system has connected this particular type of extension to Prolog automatically. So the extension is Prolog, PL. Okay, so you can see over here the type is Prolog source. Okay, surfax and करते हुए static डाल दिया आपने. Doesn't matter what, that was just a simple example. So edit, let's say edit with notepad. All right, push. Okay. So there we go. Once it is saved, all you have to do is to double click. The program that I just wrote for the family tree of this English monarchy, I named it genealogy. So if I double click it, Prolog will open it and read the whole file and know it as the engine. Facts and rules. We will discuss about it, these terminologies. So there we go. So what does it say? It says that this program genealogy.pl is now loaded. Okay. And whatever the version and all, it is all there. Now let's ask it that who is father of Sophia, because we made a rule. Let's open them side by side so that you have an idea. Okay, now rule of father. So we are going to ask it that who is father of Sophia. So X is father of Y. So we know what is Y. तो हम यहाँ पे लिखेंगे father X Sophia. See, we can write any goal for rules and facts. What is a goal? Goal is a question that is asked against all the rules and the facts. We already know what is Y. We know the Y is Sophia, Sophia, but we don't know X. So we actually had given a variable. So system will find the father of Sophia and will populate the X, will assign the value of the name of the father of Sophia to X. But you have to put this dot there, enter. So it says that X is equal to George 1. So what computer does, as soon as it finds this goal, this is a goal. Goal is a question, a query. So it takes this father and looks in the list where the father is. It sees that father is there. Then it says X, so X is there, doesn't matter. And then what is the value of Y? Sophia. So now Y is Sophia, X is unknown. The system is now trying to find what is the value of X. Then computer will move on further and reads this fact. This says that X is parent of Y. Now the value of Y is known, that is Sophia. So now system will go to parent and see where the Sophia is found in X. Sorry, in Y. So Sophia is found here. So this is Y. So they both matched. This parent is matched as well. So it means that the value of X is now George 1. Now it goes further. Now it takes George 1. George 1 is taken into X. Now the value of X is known. Now the value of X and Y both are known. X is George 1, Y we have given already, Sophia. System will now go and will check if X is male or not, true or false. So it will start looking into male. Male James 1, no. Male Charles 1, no. Male Charles 2, no. Male James 2, no. Male James 1, sorry, George 1, yes. So the part of the rules are 2. This is found and then system goes further and it is found as well. Now this is found in terms of discovery. This is found in terms of true and false. This has been discovered, X, the value of X, George 1, from here. And then that George 1 is checked if it is found in males. Yes, it is found in males here. So when it is true and it is found, it means that the whole rule will turn up the value of X, that is George 1. Our goals may be very simple, like who are the males? So I will be like male X. Variable could be anything, X, Y, Z. Let's make it M, bada, but it should be capital. So it will now start telling, you see, in previous answer, when the answer was told, a point was put by the system itself. Now there is no point there. If I enter, it will be ended. But if I ask the same command once again, and I use semicolon, it would go on. With semicolon, if there are more than one answer, they start appearing. Semicolon, James 1, Charles 1, semicolon, Charles 2, semicolon, James 2, semicolon, George 1. Now the system has put the dot by itself. So dot is saying no more males. Okay, and similarly, if I like to know that who is the parent of who, I'll be like parent. Now this time I'll be using a variable with capital W. So who is a variable? Who is parent of who? Now system will tell that who is parent of who. Full stop. James is parent of Charles 1. Elizabeth is parent of James 1. Charles 1 is parent of Charles 2. And if I put full stop, it would stop there. Now, let's make it proper parent, comma, child. Now this will not contradict with this fact parent, because this fact parent is with lowercase, and this parent over here or this parent over here is actually the variable with proper case or the camel case or the init cap case. Okay, so parent James 1 is parent of Charles 1, semicolon, Elizabeth is parent of James 1, and it will go on and on and on as many times as there are parents. Okay, now we can ask, here we ask that who is the father of Sophia. So we can ask it vice versa. Okay, so let's say we ask that what are the children of, let's say, Charles 1. So we can say that father Charles 1, comma, child. False. Spelling. Charles. Charles 1. Charles. Charles 1. See, child is Charles 2, child is Catherine, child is James 2. So there are 3 children for Charles 1. So we can ask vice versa. We can name a person and ask for the father, and we can name the father and ask for the children. This is up to you. Now let's find grandparent. Who is grandparent of who? Let's say we want to know that who is the grandparent of James 1. So grandparent. Grandparent. Who is the grandparent of James 1? Sophia. That's it. There is no further grandparent. Get the idea? So this is grandparent. Now similarly, I want to know that who is the grandfather of let's say Elizabeth. Grandfather of Elizabeth. George 1. Okay, so this is now told. Now we can ask that we can ask so many questions. The grandchild of anyone, let's say grandchild. Who is grandchild of who? ये कर लेते हैं. Charles 2 is grandchild of James 1. James 1 is grandchild of Catherine. James 1 is grandchild of James 2. Elizabeth is grandchild of Charles 1, and it goes on. Okay, so that is how we can ask questions. So whatever the question that we asked, like this one, or 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 this one, they all are called what? Goals. These are what? Goals. These are goals. So any query that you ask to this system is called what? Goals. Now,